All right. Hello, everyone, and welcome back. I've been away a couple of days just because I've been busy doing other things, but I haven't. So I haven't been able to stream, but I have still been able to do a little bit of development. So I will show you what I've been up to. If we just start the game, you might recognize this triangle. However, look at this. This triangle is in 3D. Now it's very dark. And the reason why it's dark is just because I haven't created any normals for it. All the normals are 0. And I added some light. So let's actually go to the tetrahedron. Yeah, this normal. I think I have a normal function. Vertex normal. Well, okay. So let's try that. Because this tetrahedron should be centered around the whoops, not the UV. What am I doing? 1. It should be centered around the center, so every vertex is its own normal. If that makes sense. Right. So yeah, we have a light rotating around the object in the middle. And we can move in 3D also. Of course, I'm going off screen immediately because I don't know where I am moving towards. I'm moving towards this point, I believe. So if I'm pointing it towards the camera, we can go towards the camera, we can go away, and we can turn around, we can go sideways. And it will wrap in a moment, yeah, there. So yeah, that's what I've been up to. I've been making this in 3D. Now, if you're curious how I did that, I found this article, Gaffer on Games. It's still up. And he's just explaining how you can take a quaternion and multiply it by a delta t. And then you get this thing he's calling a spin. And then you add that to your current quaternion for the rotation of the object, and then everything kind of works out. Let's take a look at the math for that, maybe. So that math is down, not in component, but in game. Yeah, right here. So we have the spin velocity, rotation velocity is defined in the prefab itself. And that's just a normal V3. So we can add values. We can add in each direction a value for the rotation velocity. And from that, we calculate this spin quaternion. And then we multiply it by the delta t. And then we can multiply it by the current rotation. And then at the end, we are normalizing it just to keep it within to keep it to be a real rotation, because if it's not normalized, then it kind of goes out of bounds eventually. And then I do something very similar with an impulse. And an impulse is just the same thing as a force, but over a short amount of time. So it's exactly the same thing. We are taking the impulse and rotation and getting a direction for that impulse. And then we add it to the velocity as a... This is essentially an acceleration. So we add that to the velocity, and then we add the velocity to the translation. And then, I'm calculating the impulse for every frame individually. So only when I'm, for example, holding the button, I will be getting this acceleration. And this impulse, I can do it positive and negative. I don't really have a way of stopping the entire velocity right now, but those are just details we will get to. And then I added the light. So the light was quite simple. If we look at this one here, so in the shader I added this normal, and then using the normal I have this matrix for the inverse of the vertices, and I forget the exact math here. The math 3, it's because it's not having the position included. So this is like just a small optimization. You could add math 4 here and it will still work, I think. But basically, this is the inverse of the vertex model matrix. And I realize as I'm saying that it's I don't super understand it. It should be down here. Model normal, I guess. Is that it? Okay. So I guess this model normal, I have M4 normal, and that is taking the inverse of the entire matrix. So actually, if you go here, you can see that they have special purpose inverses for other things, like you have inverse orthographic, because it only takes parts of the matrix. I'm just taking the entire thing because I think that made sense. And then at the end, we are transposing it also. And that gives us a normal matrix, I believe it's called. So it has a specific definition. You can read the Wikipedia page about it here. So it's something that when you are multiplying this matrix with the original, you get like the conjugate transpose or something like that. So anyway, we are using this normal matrix to calculate the normal values, the normal vectors for the light. And I forget the exact reason for it. It might be because the light is inverted. It's going like from the source to, no, it's going from the destination to the source. So that might be the reason why. And you want to do it without the translation. So, I honestly just kind of copy pasted this a little bit. So maybe I will investigate that further, but that's what it is. And then we get the normal here, and we are, dotting the normal and the light direction just to get the angle as a strength. And I guess we don't accept negative values because they could be negative. So I am capping it at 0. And then it's just like normal multiplication. And then we get the color out result. Ambient also we have. So that just means that it's not completely black on the dark side. And you can like play around with this. If it's like something like 0.3, it's way too bright. If it's 0.01, it's maybe too not bright enough. 0.1 for now, I think makes sense. So yeah, that was the light. Then I have also been working on another thing, which is this function right here. So we can now generate icosahedrons. And if you don't know how that looks like, here we go. So this is an icosahedron. And I think this is actually divided once. Let me turn that off. It's in OpenGL. We don't have it open, I guess. Here we go. Yes, this is an icosahedron, and ignore the texture for now. You can still see the shape of it. And it's just created as, it's like 3 rectangles. There's an interesting visualization for how to construct it. So yeah, here you have 3 perpendicular rectangles. Now I forget if the rectangles are like 1 over 2 pi or if it's like 1 over 3 or like 1 over like something. It looks fairly larger than root pi or 2 root pi maybe. Yeah, anyway, essentially you get these rectangles and you put them perpendicular and then you add the corners together, and every corner together that is next to each other, they create these triangles. And that's what you get here. So this is like a sphere that has equally an equal amount of detail in on every side. So that's compared to a normal UV sphere. So a regular UV sphere you can see that the detail is very low around the what do you call it? Around the equator, right? So around the equator, you have very low detail, and around the north poles, you have very high detail. Then also, because you have high details, it means that the UVs are pretty small here. So you can have the UVs look pretty good around the like majority, 80% on the sides, and then the top and bottom are, kind of low detail in comparison. And you will notice that if you look at the world map, with lines, I forget. Grid lines. Here we go. So small. But you see my point, right? Like Greenland, true size of... If we take Greenland here, it's actually only the size of, 1/10 of the Sahara or something. But if you compare here, it looks like they are about the same size. So because of the position of Greenland, the further north you go, the more it like blows up. And that is exactly because of these lines. They all converge in the same spot here. So essentially what I'm saying is that you don't have... is a very uneven distribution of detail. And these things are mapped very accurately, like around the equator, and then everything that is not on the equator gets very, very distorted. Now that's fine if you want to make something that is a sphere that doesn't need to have, a huge amount of detail on the poles. But I would like to try to do something... I would like to generate spheres that need to have like this uniform amount of detail. So that's why I chose an icosphere. And the cool things about... one cool thing about icospheres is that it's very easy to subdivide them. So I have this... not this one. Here. This icosahedron... We're creating an icosahedron, and these are kind of hard-coded values based on some number here. And I'm sure that I could, take this size and multiply it maybe here. But yeah, I have this static vertices, and I set them here, and then I can also multiply it by the size. And I have faces here where I do something. Why do I calculate the dots? Oh, so I'm just checking here that the faces are actually facing the right way. It's not strictly necessary. It's just for debugging. Face. Okay, and here I'm actually setting the faces, which are the indices. Yeah. What we can do is we can subdivide it, and the subdivision is fairly simple. If we are having a triangle, this is one of the triangle faces. We can just take, if this is A, and this is B, and this is C, then we just take the middle between here, here, and here. So we create a new vertex on each of these places. And then we create 3 more faces and delete the original face, so obviously. So if you do this, then you can just take these vertices and you can normalize them because they're on the sphere in the correct place, but they need to just be like extruded a little bit to make it more round. And when you do that, once. Maybe you can already see that it's getting a bit more rounded. Now, you might also see that we're having some kind of seam here. So because of the issue with this type of mapping is that there's no obvious seam to put it. And I'll show more about that later. But like the majority of the sphere is like pretty decent, like here. But then you have like this one seam where you get a bunch of what is it? C2, C3, C4. It's the same as these ones. And the reason for that is again, well, not again. The reason for that is because there's no obvious seam where I can unpack it. So it's just like projected using a very simple formula. And it's overlapping the vertices in some places. And it's just like bunching them up in one place like this. So it will be even more obvious if we go even higher on the subdivision. So let's go to 4. Now 4 is pretty overkill. I don't think I'm going to have a lot of 4 icosahedrons divided by 4. But you see, this is very nice. Like it's upside down, but never mind that. So this is very like evenly distributed. Oops. Well. It's a little bit hard to control. So yeah, it's very evenly distributed up until like the very, very top here. And then you have this seam right here going on one side from the south to north pole. Can we do 6 just to see how it looks like? No, 6 I couldn't do. I ran out of memory. Let's do 5. 5 is pretty high. So 5 is like 10,000 vertices, I think. Can we go closer? Now, I don't have a way to stop the sphere. It's still moving tiny bit, but that's fine. So yeah, this seam is actually very uniform in a way. So my goal today is to see if I can't make this seam a little bit better. Or like, let's see if we can improve this in any way. It doesn't have to be perfect like this, but this seam specifically, I think you should be able to manually like stitch something here. No? And if we go to a render doc, I found out a way to let's make it larger actually. Why not? Yes, 61,000 drawn 61,000 triangles, or is it 61,000 vertices? Anyway, it's a lot of it's a big number. And here is our sphere, and you can see that it's like very well subdivided, very even. Can I make it not see through? Yeah, like here's one triangle. Now, one issue with this, you can see all of these are close together simply because they are, that's how they were generated. But then you go to the next one and it's like somewhere completely random on the sphere. And also if you look at the indices here, you go 0 and then 25K, 0, 25K, or 2500, I mean, 0, 2500. And there's, apparently you can optimize this so that all of the, you can map out all of the triangles and you can rearrange them so that they're all close together in memory and in indexes. And that is an optimization that you can do if you really care about it. Now, the problem is I want to generate a lot of different icospheres to make asteroids. And I don't think that it makes sense to do that optimization step, so I'm not going to do it. But just to mention it, if you would be doing this yourself and you want to like generate something better, then that's something that you would be looking at. But yeah, we can actually set the UVs as a position and see how it looks like. Now, this is actually really cool that this is how the UVs are arranged right now. And you can see that it goes very close to the edges. Oh, it goes outside of the edges? No, that was just a perspective. But yeah, so the issue here, as you might notice, is that you have overlapping UVs. So here's one UV, here's some UV, one triangle, and then you have something that's going across it. And I think that's exactly it. So if we go here, you have a triangle. Is it too close? You have like some triangle on the surface and those look good. And then you have these lines that go across the entire surface of it, basically. And I'm wondering if there isn't a way to just force it to be on the edge. There's so many of them too. Yeah, the cool thing about this algorithm, so I can show you the thing I'm doing. For some reason, this Unity 3D wiki thing is removed. So I had to go to Wayback Machine. Yeah, it's this thing. It's just this piece of code right there. So yeah. Now it's actually pretty interesting to me because I looked this up after making an attempt myself, and I noticed now these values I got from somewhere else, but like maybe they were first created here. I'm not sure. If you look at my values here, you notice that they are the same 0, 11, 5. So I might have gotten it from like a source copy from here, but then they go on and do maybe it wasn't this one. Because what I do in my subdivision, I am checking if we are having a new vertex or if it's a duplicate of an existing one. And I do that by checking the faces and then taking the smaller one, ORing it with the larger one, so I get like a unique value. And then I just like look up if this has been generated before. And if it has, I'm just using that. And if it doesn't, then I am generating, like creating a new one down here, creating a new vertex. And I noticed on some of these that they were doing exactly the same thing, which was pretty funny that I just like reinvented exactly the same method for doing that. But yeah. So anyway, what I wanted to try was if I'm generating these normals, let's put this at 0 for now. And we can see what that looks like. Oh, and I should move the game window back to the right. I think that's the settings. Or maybe before we continue, I should just go over the last things that I changed. Let's see, it's somewhere here. Oh, okay. I don't know what it could be. 500, maybe 700. All right, let's make it 800 and make it times 4. I just want it to show up on the stream very well. Okay, so maybe 5 and 900. Yeah, well, thank you. All right, that kind of works. Let's do 6 actually, and then let's put this at 100, and then I think I'm done. No, great. So yeah, again, this looks good. I don't know why this is upside down while my other one is not. Maybe I'm reading the image upside down. Anyway, we can just go to the shader. All right. So as you can see here, oh, it's actually backwards also. That's interesting. D1. So in case you wonder, I added a texture here and it's called UV test yoga. I got this from the internet, but we can open it in my yoga viewer. This is how it looks like. And every rectangle here, or every square, is 100 by 128 by 128, and the full thing is 1024. And it just allows us to map everything out. Now I'm actually using my own image type for this. It's in main. So yeah, we are reading this file. We are decoding it. And then we're creating the texture. And actually, I seem to have forgotten to arena pop. We are popping what? Scratch arena. BMP. Is that a function I have? Really? Also, this should be called file free. File create, file load. In main.h. No? Ah. Although I'm not sure it should be part of the game one. I don't know. Maybe it should. Why is this incompatible? Yeah, Clangd is having a real issue right now. I'm not sure why. File create. Size, arena, name, file type. I32. Oh, wait. It's the entire file that is alloc, not just the data. But here, it's different. So that's not good. Um, so let's see. We open the file. We get the length. So length and size of file. Into file result fread result dot data and yeah, that data is there. And then we close it. This is pointless. And then we return results. Right. Where are we using this function right now? Why are you complaining? Conflicting file type, or is it not the same? Wait, do I have two functions? Oh, that's why. Ah, so why did I have a to do there? So this already works. But then when we are freeing it, we need to pop what we need to pop. Yeah, we're allocating the entire file. So the pop needs to do I guess this is void. Why are you complaining? Okay. Maybe I will add a reference to the arena as well eventually. I don't know. We'll think about it later. So failed. I hope I didn't mess up too many things there. Yes, it's still running. It's starting from D. So you have D1. Okay, so it is in the middle. D2, D3, 4, 5, 6, 7. And then around here, you get a seam. And then instead of seeing 8, you get the same thing but backwards. This entire row backwards, like this. So I'm thinking that we can create a seam there. If we look here, we look at the UV as a position. See, here's one seam, and here's one seam. If I can select it somehow. There. And probably here's also one. And that's one, and this is one. Right? And they're overlapping. I'm also not so sure I want it to be all the way to the edges. Because I don't know how to move this. Like, this works, maybe. But yeah, you can see here, this entire thing is perfectly aligned with the top. And I think I would like it to be farther from the edge. That makes sense. So is there something we can do here that makes sense? I think essentially we have, which vertex are we talking about? It's this vertex here, number 7. It has the UV x equals 0. But you can also see it's having the Z value 77. Hmm. Vertex 10. How do you look like? Starting from 0, so it's this one. Minus B and minus A. Really? Because this is essentially 0. So yeah, this one. All of them are having 0 in some direction, I guess. Negative and positive. It doesn't make sense. Oh, that's the output. Here's the input. So I guess it must be 7 then. 0, 1, 2, 3, 4, 5, 6, 7. So yeah, positive A and then negative B. And how can we tell that this is on some edge? Is there a way to get the actual texture on top of this? All right. So it's in the middle towards the camera. It's this vertex right there, I think. I'm trying to just think. I want to take a sort of rule where I grab this vertex and, this vertex, and I like keep them on the edges. There's another vertex somewhere. I'm not sure where. What if I just literally say, oh, uh, V is at the top? Okay, so this would be 1.0. So what I'm doing now is, for the 7th one specifically, I am putting this vertex in this corner. And I just want to see how that looks like. There. That did nothing. It looks the same. Was any of them... Like, there should be one UV somewhere that is 1 and 1. Or here? Eh? That does make any sense. Like, I literally set it to be 1. What? Hmm. What is going on? Oh, stupid. Yeah, okay. So that does look different. I wouldn't say it looks better, but I guess we'll find out. This one. Hmm. That's the wrong corner. Let me not invert the shader thing. I don't want to save it. Launch. Oops. Okay. The seventh one here. So I guess now we should put it at 0, 1. Oh. I didn't expect that triangle to stretch like that. Okay, so I had another idea. So my idea was this. We take U and multiply it by 0.5. And then we say if X over, if it's positive, yeah. So the logic behind this is that I am multiplying by a half to, you know, divide it into like I'm scaling it down into a smaller area of the UV map. And then in the case that the X normal is the X of the normal is positive, then I'm adding 0.5 so that I'm like dividing it into sort of like two islands. That makes sense. So let's see how that looks like. Did I even compile it? This is interesting. So like if we just look at these ones, right? It's pretty obvious you have like 2 negative x, 2 positive x, 4x on 0, and then you have 2 positive and 2 negative. So there's 4 positive, 4 positive, 4 negative, and 4 0 ones. So you can, like, I don't see a reason why we wouldn't be able to unwrap it mathematically. So you have this edge on the like x equals 0 or something. And you have this other one where x equals, really? So which direction is 0? Oh, this one? Okay. Minus 42. It never reaches 1.0. 50 is the size. Now, when you subdivide this, you're going to get, are you going to get as many on 0 as you are going to get positive and negative? Okay. So now we're doing only if the x is positive, we are creating these normals. So here they are all 0, and here they are all like sort of bunched up. It's still overlapping. I don't want it to overlap. One triangle is... One of the triangles are in the 0, 0 corner. Index 4. Because if I do this, it's going to be the same problem, because the ones that are at 0 are going to be attached at the ones in some negative place. So this is actually really nice. But it's like all these that are attached to something. What if I do that? I got my faces, and then for each face, hmm? What do I do? All right. So what I'm doing here is I'm going through all of the faces. There's 20 faces, and I go through each indies, and then I'm checking if they are positive. And if all of them are positive on the face, then I'm creating this UV. And otherwise, I am ignoring it. Hello, Rauf Tuati. I'm sorry I didn't see your message there. Do you need experience to start making a game engine? I would say yes. However, you can just start doing. You need to start somewhere, right? You need to gather experience somewhere. So I would just say start simple and take it one step at a time, and then you will eventually you will gather enough knowledge to do everything. Why C and not C++? Because I like C more than C++. Okay, that didn't help. See, the thing is, I don't know how to. I don't know how to create a seam without duplicating vertices. And I don't want to duplicate vertices if I can avoid it, simply because I want to manipulate the entire sphere. And it would be really annoying to subdivide the sphere and manipulate the vertices. And then I have to also keep track of duplicate vertices. Is it possible? Okay. So essentially, it's impossible to not have this overlap. So then my question would be, is there a point where I should duplicate vertices to create the seam? Or should I rely on some kind of library? Or are there even libraries for this? So we have X Atlas. But I feel like this is more a tool for creating assets on the fly, which is fine, but I don't know. Python, CMake, what is going on? It seems a little bit overkill for what I want to do. So there was a YouTube video I saw. Let's take a look. Right. This video. So he was having a link here. But of course, if you go to this link, it doesn't exist. So again, we have to go to Internet Archive Wayback Machine. Hello? We have a triangle mesh resembling a sphere. The white line is the boundary. Yeah, these long lines. So apparently he had some solution to this. There are a couple of other things. If we can detect when a triangle gets flipped. What do you mean flipped? Aha, okay. So let's put this back here. So we can do the same thing as here to calculate if it's like upside down, this triangle. So I see what he's saying. Let's build this. So we have, let's say, here's one triangle, right? And you can see that it's going counterclockwise. So it's top, bottom left, bottom right. That's a counterclockwise winding. But this big one, this is having a clockwise winding. So that means that it's upside down. It's flipped. And we can detect that using some the same math as this here. So that makes sense. Where was it? Here. Now the issue is, of course, this vertex is also being used for this triangle here, which is having the correct winding. So it's not as easy as just like removing the vertex. Okay, so we have the indices of the flipped triangles, and what do we do with them? Wait, what? So he's duplicating the vertices. That's it. So like, if I would do this, then I would have to subdivide immediately. You know what? Let's just try it. That was here. But how is he calculating the new UV? Is he just recalculating with the same function? If X is less than 25, try get value. Do you know what? Let me let's take something like this. This is, you know, the moon. And I will show you a technique that is pretty cool. Because before I start like fixing things, I want to see how it actually looks like. So we need to make this square. How large is this? 800, 500. So 500 by 500. Okay, that looks fine, right? 300. Yeah, crop to content. No, crop to selection. So the way you make a texture wrap is you, oh, it has some copyright stuff here. No? Is that a watermark? Is this not free? There's definitely a watermark on this. So maybe I shouldn't upload it. But it's fine for now, just to, you know, try it. So yeah, the way you do it is you duplicate it and then you move it down by half of the size to 250. And this other one, you move it up. And then we can merge them. And then we do the same thing in the X and Y. So 250. Now you see barely a seam here, and you see a very clear seam north to south. So we can take the healing and try to remove the seam. You know, something like that. You know, that's already pretty all right. So we can export this. And the cool thing is that this is wrapping now. It's like you can tile it infinitely. And I can show that just by taking the canvas size times 4 something, or maybe like this. Oh, I should make this layer the size of the image. So yeah, you can see now I moved this over here by 500. And ideally, there should be no seam. $500 and like that. So like there's no seam here. Like you might say that, oh, this looks like it was edited, and that's because it was, but it's good enough for testing. So that's cool. So now let's go in here actually and go to, well, first off, I have to open this with, can I open it with, cool. So we can change this UV test to the moon just to see how it looks like. You know what? Maybe it's not that bad. Let me try with some subdivisions. Well, this is very obvious. Though I wonder if you can hide that. All right. So anyway, I think I will think more about that later. But what I would like to do now, before we finish up for the day, is I wanted to do some randomness to this. So I actually already have made in my TFL tools I have made this random library, and it has two things. It has a hash generator, and it has a randomizer according using this implementation basically, or it's based on that. And the way we are using it is we are creating a seed. So the seed is this thing. So let's go to the component here. TFL seed. And we need to have this TFL. Seed, generate seed. Now this is the first time I'm actually using this, so let's see how it goes. Seed init. Init state. So this is like our, like this is our seed value. And I'm just going to put 0 in here. So we are, we can run this a bunch of times. So let's do here U64 rand val equals let's see what kind of values we get, right? So this should be like a value from 0 to U64 max. Or is it? It's all high values. That will give me 0 every time. 75. Okay. Do I use their IM GUI? No, I don't. I have used it, but I'm not right now. Okay, that's fairly good actually. So I literally don't care about the accuracy because it's random anyway. So this might be a little bit like on the edge of what is giving you rounding errors, but like it's a random value. Who cares? So what I want to do is I have a hmm? Yeah, let's remove this. So not for each face. The position here, let's do I think actually this already is normal. I can double check that. But anyway, we take this plus vertices I times, let's just do like the rand val directly. And well, it's not C++, so I don't have overloads. So what I'm doing here is I'm taking the vertex and then I'm multiplying the same vertex with a random value between 0 and 1. So basically now every edge is going to be a little bit the size can be from 1 to like twice the length. So that will make it look a little bit different. Well, now you can see what happened here probably. These ones are the ones that were actually extended, but then what my subdivision wasn't taking that into account. So that looks funny. Let's do here. Let's do this 0. Okay. You know, it's a little bit big, but I think that looks good. Now this is going to be exactly the same every time because I have like my specific vertex, or I have my seed value as 0. And that's why I didn't want to use like math.random. I wanted to have control over the seed. So now every time I'm generating this particular asteroid, it will look exactly the same, even if it's like a randomized thing. And honestly, I think that looks pretty good for what it is. Just like the immediate thing. So, but we can make it even better. So I probably want to associate this. I'm gonna throw this random seed on the state for now. But eventually, actually, okay, never mind that. I will just do exactly the same thing, but this will be replaced eventually, is what I'm saying. So again, here in the subdivision, I do the same. So this will be not here. But it will still be static because just of how the code is running right now. And I want to do exactly the same thing. So we go back to the previous. You'd like my opinion. You have been learning C++ and recently starting getting into graphics program with OpenGL. Since C++ roles seems less common than backend jobs, is it better to keep going deeper into C++ or switch early to a field with more opportunities? I have no idea, dude. I am also looking for a job, and I know that there's fewer opportunities, but they might be more. They might be better. So like, but also you kind of have to stand out more. But then by the fact that you are able to develop in that kind of way, it also makes you stand out. So like, I couldn't tell you because I haven't worked professionally as a developer full time. I have had development in my previous career, but I was never hired. I was never in this like IT role. So I am completely self-taught. I didn't learn programming in any university. I just learned the math basically. So I understand most of the math, even though it was like so many years ago. I forget most of it, but like I can get around it when I like really think about it. But I can't tell you anything about the market aside from the fact that I have applied for a few jobs and I'm just getting ghosted. So I don't know. Probably it's I think probably it's beneficial to have knowledge of it, but then they still want you to do the like networking stuff. So who knows? I can't I can't tell you. So I'm sorry about that. Right. So I am doing this. And then we're multiplying by the size. So yeah, I want to do the same here. So we're creating a new vertex. And here, like depending on the level, maybe we don't want to do like a full 0 to 1. Maybe we have to make it smaller because like we're adding finer details. But yeah, let's do this. Get the normal. And then we multiply it by the size, but critically. The new vertex. So we do the random next, rand val. So this is going to look a little bit crazy. I forget actually to. Really? Let's put it on level 1 and just see how it looks like. Yeah, now it gets a little bit crazy. Also, did I forget to multiply by the size? No? Wait. Something about that looks off. Like basically all of the new vertices are just right at 0. So why is that? I guess I have to debug it. So I'm taking the new vertex. This looks normalized. So we take the new vertex and we add this. So it's like double the size, right? And then we're multiplying that by some size. Huh? Okay. And that's should be good. So why is it bad? Is it the original ones that are not good? Aha. So how did I forget to multiply by the size here? Hmm. Oh. Why are you tiny? The position multiplied by size. Oh, what is this? Why did that happen? Okay, now it's good again. So we are adding back the subdivision. Okay. Now you can see that all the new ones are only additive. I would like to do something different. Component. Let's do minus 0.5f. So now it's in the range from minus 0.5 to 0.5. Oof. That is not good. Imagine being a developer because AI is going to take your job. This is a joke, as I'm also a developer. I wanted something almost funny as a first message. Right. I mean, I don't believe AI is going to take that many people's jobs. Like, I'm going against the consensus maybe, but I'm just going to say I have still never seen an AI do a good job of something that is like actually worthwhile. So I haven't. You can ask an AI for a snippet of code and it will give that to you, and maybe it will work. But you can't have an AI, or at least I have never seen an AI develop an actual application, like from start to finish. Here's an app. Here's like on your phone or a program or some website. You always need the person who is guiding it and subdividing the tasks into something that the AI can actually handle. And even if it does handle it, you have to verify that the output is actually good. And that's just my opinion. I know that maybe I am more pessimistic about the whole thing. yeah, AI is trash at most things. Like, it's just good enough that people can think that it will replace you, but when you actually look, like, because like literally look even at translations. So I think out of the jobs that are like the biggest threat right now to jobs, I don't think it's developers, I think it's translators. But even translating, which is like the it has the best opportunity to translate, let's say, from English to German or from Spanish to French. Like, there's so much training and opportunity for it to do that translation well. And 95% of the time it does work. But if you have read any book translated by an AI, like not just, a page where you need to understand what it's about. When you're talking about like an actual work of fiction or something that you want to read for enjoyment, it is so bad every time. It's never good. Like, sometimes it does an okay job, but like there's just no replacement for real people going over it. Now, maybe you can use AI as a tool for like most of it to like speed up your work. I don't believe anyone is going to be like twice as fast translating using an AI. Maybe it will help them, being a quarter faster or something like that. But yeah, I think it's like a huge bubble right now, just like, .com or something like that 25 years ago. So like in 99, there were like so many, like thousands of internet companies betting on the fact that they would be like the next big thing, or ordering dog food from your house. Like, what a novel idea. And then, you had the bubble crash or bubble pop in like 2000 or 2001. And huge amount of the market was just like sort of corrected for. And a lot of companies went bankrupt. And now, like, okay, the market is higher than it was during the bubble. But now the things that are like, I'm using the internet every day, and the internet is huge for a lot of things. But like, we pruned it down to the companies that actually worked and to the services that people actually need. So like, it didn't happen that, people are buying 99% of their things online, but they're buying maybe 20%. And, I feel like it's the same with AI, that people are talking about every creative job, art, writing, translating, programming, music, like all these things. Maybe it can't, like, it's not going to replace 90% of those things or 50%. Maybe it will replace 10%, or maybe it will just replace maybe it will be just like a novelty. OpenAI has made a net negative. Like, I don't think OpenAI has ever made any money. Have they? And I think it's so telling that you have OpenAI, which is like a huge company with like burning hundreds of millions, maybe billions per year, like net deficit. What do we have? Yes, annual net loss of something like 20 billion. So they're putting so much resources, and they are having so much investment, and they're having so many millions of people working their hardest on making this work. And what is their most popular product? Or like, what's the best thing that they can figure out how to do with this technology? It's like this open AI video generator. Like, what was it called? Sora. This is the best thing that they can come up with. Like literally a TikTok app where instead of recording video, you are generating video. And that's it. And then people are making, Michael Jackson and Donald Trump shit posts with it. And that's the best thing that they can come up with. Like honestly, it's just crazy to me. I know that there's a lot of pessimism around, like from developers or from content creators themselves. But I do think that we are like near the peak of the bubble and also of the like current model capability. And if you are spending time today and working, your ass off to be the best at the thing that you want to be good at, I can guarantee you that 5 years down the road, you are going to be in such a good position compared to everyone else who just said, "Oh no, so like it's pointless. I give up. Like AI will do," or they were like using AI and like they were transferring their mental thinking to the AI. So like they don't understand how to develop themselves. They are handicapped by the fact that they need to use AI. Now you can use AI as a tool to be faster. Yes, you can use AI as a tool to like similar to Google, just like looking things up, generate some boilerplate code, tell me what is wrong, where is this bug, what does this error message mean? So you can use that to be faster. But if you are just like, hey, give me the code for making a icosahedron, and just like copy paste, and then you never like even think about it, then like you never learned anything. So now 5 years down the road, you have nothing. And then like let's say that the AI models 5 years from now, you need to pay 500 euros per month to use them because it's just too expensive to run it, and they don't have this like venture capitalist money anymore. Then you have to start over from scratch, and you wasted 5 years doing like nothing, just like vibe coding, prompting, whatever. Your favorite thing about the AI hype is people not understanding what it is and thinking that they will replace devs. Well, again, I can't say. I don't have a crystal ball, and I'm literally unemployed right now. So like if you have a job for me, like let me know. But so like I'm just like talking from the comfort of my home, doing my own projects, but I don't believe the hype. That's it. That's all I can say. I think in 2-3 years you're gonna have a lot of companies realizing that actually they need the developers that they fired, and they will like start to reverse on their policies. Like right now it's just like some kind of hype where middle managers and upper level management think that they can just use AI models instead. And at the end of the day, I feel like you can use AI to develop something, but you have to handhold it the entire time. And to actually make something that is a little bit complex, you literally need to burn so many tokens that it's cheaper just to hire a real person to do it, because you're just going to like reprompt it for fixing like stupid things over and over until it finally gets it right. But like you're wasting your own time telling it that it's wrong, and you're wasting tokens just regenerating code that someone could have written in a day anyway. So yeah. Anyway, let's get back to it. Yeah, that's fair enough. Like I learned C++, and I used it for like 5 years. And this is actually my first project in pure C. So this is like a little bit new to me as well. But the reason why I wanted to do it is because the thing I like about C++, it's like 95% the C stuff. So I wanted to do that. Right. So what is wrong with this? Do I just need to like multiply it by some factor? 0.2f maybe? Do we get the level here? I don't think so. Is it really that spiky? Okay, so that definitely something is going on. The memory management and pointers is just weird for me. I understand the logic, but the syntax I think gets to me. Honestly, I feel like the syntax for C is so much simpler than C++. Like one of the reasons I don't like using the C++ isms is because let me show you. Let's see. So there's another guy making an engine. And he's doing it in C++. And what was it? Maybe this one? I'm not saying anything about his skills as a developer or the quality of the code, but sometimes you watch him develop and he's talking about, well, this is OpenGL. Is that what I clicked? Yeah, like this is how the code looks like, and for me, it's just so incomprehensible. Like, what is this? Explicit const expression matrix for standard initializer list, angle bracket float, standard span const. Like, what the fuck is going on here? Like, this is not normal. This is not like I don't know what to say. Maybe this makes a lot of sense to someone else. To me, it's complete nonsense. So I think that what I'm doing, it's much simpler and understandable. I'm not going to say better or worse. That's personal opinion. But at least the code I'm writing is pretty fast. So you can't take that away from me. Now we needed to debug this. So random next. What is going on here? This ran val. So it's like 0.54 and now it's 0.55. And for some reason, It's way too spiky. Now it shouldn't be spiky at all. So like, okay. There's definitely... I'm having like some error thinking about it. See, maybe I shouldn't normalize because I'm taking, for example, this edge here and I'm taking the middle of it and then I'm normalizing it and then I'm doing my like plus or minus. But the normalized one is going to be all the way down here. The idea of headers is foreign to me. I have never done Java. I have done C sharp, which I think is very similar. Is like C sharp is based on the same idea like Java, isn't it? Microsoft Java is C sharp. All right. Yeah, so I've done Java and Visual Basic, which by the way, don't do Visual Basic. You know what? Maybe we get this vertex by taking the... What is this multiplied by 0.5? Ah, okay. So yeah, let's do this randomness. Let's do it here. Now I'm just like playing around with this code. Mm. The whole joke is that Microsoft took Java, did nothing with it, and rebranded it. Yeah, I can imagine that. Like again, I did C sharp and Visual Basic only for work. I never cared enough to dive deeper into it. Let's do this. Unused size. Okay, we need to subdivide it. Okay. It's looking a bit better. Let's try a high value. Oh, it it gets a little bit too rough. Maybe I would like this value should be relative to the level. Now I can get the level. Where's the subdivision? Right. So if I go here, I am getting the vertex count as a parameter. I don't know why it's 13, by the way. It makes no sense. No, phase count, vertex count, whatever. I'm thinking we can do something like vertex count 20 divided by vertex count. Okay. I don't know, like, is that too rough? It's a little bit annoying also because every time I'm calling the subdivide, I am having the same random value. I need to take a quick break, so I will be right back. All right, I'm back. And I have some cake that my wife made. So yeah, I'm thinking we probably want to keep around the icosphere code. But I don't know if I should just put the generation straight into, like, I'm thinking I should just put the subdivision straight into the actual icosphere code, icosahedron code. But honestly, for spending, an hour on it, I think that looks pretty good for, randomly generated asteroid. You still have that seam. But I don't know if we care about it. It is very obvious. I don't know. Right now, I'm having too much fun just with the asteroid in general. Now, actually, when I'm thinking about it, I think the real solution to this if we're having our, asteroid that we generate and it looks something like this, right? We can have an algorithm that just creates squares, triangles really, but like it's just doing this evenly across the entire surface. And then at the top, it does something. Something like that. I don't know. But essentially, you take the generated one and then you reskin it after the fact, after it's done generating. Okay. I don't like how deep this is. Was it always plus 0.5f? I'm skeptical. Game component. Oh, it was plus 0.5. Okay. I was just scared that I was changing something and I left it there by mistake. Why is this not enough? Okay, so now it's much less pronounced. Maybe we can find a happy medium. And that's getting pretty good. And again, let's... Oh, it's already a 3? I guess the randomness is so low. At this level, the randomness is so low, it barely has any effect. The only thing better is this seam, really. What if I just take 0.1 again? Just want to see how it looks like. It should be... So this like vertex count is increasing by the cube, I think. So maybe if I... Is there a square root or cube root? CBRTF? Whoa. Okay. How is it like that? Let's see at this. Take a look at the scale value. So the first time we're having ×4, which is pretty high. Next time it's again 4. Why is the vertex count only increasing by 1? No, something is wrong here. What? Ah. The face count is only updated at the end. All right. So I think actually the faces are up are increasing by the square, I think. So let's try. No. Square root of vertex count. Square root of 20 is 4. See now the scale is 2, and then not vertex count. .89, and there's a ton more vertices, of course. So yeah, it goes down not linearly, but like in a manner that you would expect. 0.22, yeah. So that's interesting. Mm-hmm. It's a little bit too exaggerated, isn't it? But maybe it's just because of the texture. The texture is doing a little bit of that exaggeration. $1.5. Also, I'm probably not going to go over 3. So this is more like what it would look like. How does 2 look like? That is also pretty good. Like imagine, does it look better because it's a higher resolution? So like, if I do 2, 2 at this level, I think actually looks pretty good. Now, of course, you have the issue that here it's a meteorite impact, but it just happens to be on a place on the asteroid that is extruding. And same like on the top here. So that doesn't look, that looks a bit weird. But if I want to deal with that, I have to sort of generate the texture based on the geometry. And that's also maybe a bit overkill. As a concept, this works, I think. Now I just have to grab a texture from NASA or something because apparently this one is copyrighted. Yeah, let's remove it before I forget. So this is how it looks like with the UV map. Not bad, actually. Okay. So what else can I do today? I think I've been streaming for a long time. 3 hours. So like, I would like to add. Here's the thing, right? Maybe I don't imagine that I'm going to be generating a lot of icosahedrons on their own. So let's say we give this level here. And actually, before I mess everything up, let's just push it. Right. So now we do icosphere. We take a level. What is this? So let's see if I can put this in all one function. This entire thing we can remove. This face count was coming from outside. No? Hmm? Doesn't return. Cool. Now component H. So Scratch Arena, VSIS. Icosphere. Size. Level. Randomness. Let's say 10. This is doing nothing, I think. Let's see if that just works the same. No. Not at all. So what's going on here then? Two. Actually, let's start with trying this just to understand it better. This still works. And maybe this also works. Okay, level 1 works. So there's something I'm not updating. Probably the faces. Yeah, this thing. That works, I think. You still have the seam, but you know. And you know, I can probably optimize this. This is fine for now. Hello, Ziozen. So something I was thinking about here is I want to generate based on the index. So right now I am this meteorite, let's say. This is my player character right now. That's why I can move it around. However, if I'm generating just random meteorites, then I would seed the randomness by the entity value. Basically, what I'm saying is I don't have a decent way of generating a bunch of meteorites right now. I'm only creating the one. I could rewrite the code a little bit, but I think that's going to be too much time. That bit of UV that's squashed, yeah. I was looking at. Oh no, did I close it? No, here it is. I was looking at this web page, and he's talking about how he's generating this icosahedron. He's subdividing it, and then you get this UV map. And the problem is, this is mathematically impossible to avoid. You can increase the subdivisions. So down here, I put the level at 5, right? And now you have a very detailed mesh. It's like 10K or 40K vertices. And this zipper, as you called it, still exists here. Oops. How do I go closer? It still exists here, but it's much less prominent, right? And similarly, if I have something like 0, it's not so noticeable simply because the level of detail is much lower. Now you still have artifacts like here, but you know, without duplicating vertexes, it's pretty much impossible mathematically to unwrap it differently. And right now, I would rather keep it simple because I just want to generate new UVs with a very simple formula like this. I don't want to start like chopping it up until I know that, okay, this is my like final version of the thing. But I can try some different values for a randomness, see how they look like. Now I'm wondering if I should add some noise, maybe only to the. So I what I could do is I could add randomness to the position of the vertices, not only the magnitude, right? This is basically doing randomness to the magnitude. But like this, right? Oh, actually, let me do a very simple. I want to do exactly this. Maybe I have to inline this actually. We will see. Even a cube would not be tiling perfectly always unless the texture also tiles symmetrically. Curse problem. Yeah, exactly. The issue is not that you, like, if you have seen a cube, UV, the typical way that people are unwrapping them, like here, is like this. But what you will notice if you think about it for 2 seconds is that the corner here is shared with the corner here. They are the same. So without duplicating the same vertex twice in order to have different UV values, you can't map it without like having some kind of overlap or something like this. So without unwrapping it, without duplicating and unwrapping through some algorithm, this is the best I can do for now. And I think we will see how it looks like. We will see how bad it is, and then we can, you know, if I become a millionaire one day, I can think about it then, right? So, rand F32, or maybe F32 rand. Just an easy macro. So we can do V3 rand dir. That would be rand. And also, I just realized I didn't actually finish this. Seed and seed. And I guess this should be, you know what? Let's just do an inline. Why not? And F32. You know, why complicate it? Now we can just do equals to this is not even good practice because the randomness could be different. No? Oh, rand. Y, Z, and then we do randr equals V3 norm. And then we do also small amount, like really, really tiny here. And then I can do this pause. Okay. So now I'm just adding a completely random direction. So now we're not keeping this like uniform circle. that does mean that I have to recalculate the normal as well. But how does this look like? I think that actually is pretty cool. It's more natural that way, right? So normal, right? This not just taking the norm. Yeah. So why is this a function? It has been successfully transformed into the shape the professionals called a lump. Exactly. Well, it's actually pretty interesting. Like it's hard to make something organic. Oh. And so like here's my idea, right? Just to tell you very, very quickly. Every time I'm generating a new thing, a new entity, I give it an entity value, entity ID. And it's a U64, so like it will never run out. So the first asteroid I'm generating, let's say it's like at ID 24. And then I want to generate like 1,000,000 asteroids. I don't have to have them all on screen at the same time. But I have 24, 25, 26, 27, and so on. And all of them, here's a sort of planet, and here are all the asteroids in, a ring around it. And here is the player and their like range of vision. So when you are here, based on the time, just purely based on the time, you can tell what asteroids are around you. So like you might say here is, the this number of asteroid right there. So then I'm generating this asteroid using my random generator, but using that as a seed. So it always has the same shape. And that means that, you can play for an hour and you can go to you can stay around here, or you will go around. The player's going like blah, 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 blah. And then, 20 hours later, he goes back here, but actually it's over here now because of, they are all orbiting according to like the schedule. And then here you have, the same asteroid 265 or whatever it was. And then the mesh has been deleted since like forever. But because we have the same seed, we can generate exactly the same asteroid. So that is my idea, to have a sort of blend of, everything is predictable. So like everything that exists is there statically, but nothing is stored. So I'm not saving any meshes, and I am not. The only thing I might store is, for example, if I destroy the asteroid and then it doesn't exist anymore. And then it can just like look up, it can hash the asteroid ID that it's expecting to be there and just look into a hash table if it's destroyed. And if it's destroyed, we're just not generating them. Yeah, that's a very short what I'm planning to do. but I'm just having fun generating some meshes right now, it's pretty fun. Like honestly, the math is pretty simple for the most part. Like of course UV is a pain. But let me try to do the same here in the later stages when I'm subdividing, creating a new one. And here we are having this randomness, right? So we're doing the same thing. If randomness, that's where it goes, right? Yeah. This is the yeah, we're getting the normal afterwards. So that's fine. I might have to multiply this by 0.1 again. Oh, yeah. You see, this is too crazy. Now it's starting to like overlap with itself. That's really not what you want. That's still way too much. Well, if it's 0.01, it might not even be worth it. No, something is going on here. Hmm. What is going on here? Some see now it's good. Oh, I see. That makes sense. I'm wondering if that even makes a big difference. Like it's lumpier, but I don't know if it's better. Yeah, exactly. Yeah, maybe we don't do this for that part. I don't think I like it. It's too chaotic. This is like already good, I think. So yeah, I think that's about it for today. Let me take back this moon texture. And now we can generate as many as we want. Although I have to recompile for every new one. You know, from some angles, it looks really good, honestly. Now it's not perfect. You can see right there if I can actually, like here, you see this is not very good. But I mean, honestly, how close are you gonna look at this as a player? So yeah, if you want to generate your own asteroids, maybe play around with the math. As always, you can download the source. You can download the source. I think the Emscripten version it has some issue with the shader right now. But the Windows one works. So, you know, feel free to play around with that. But I'm going to delete this moon again because I don't have the like rights to that particular asset. Game. Yeah, I'm gonna try to find a better one that is free. Yeah. Thank you so much for watching, and I'll see you guys next time.